Cool.
Hi, everyone. Yeah, we have just been presented, but I am Javier Blanco. I'm Senior Data Scientist at Quix.
And I'm Tomas Neubauer. I'm CTO and co-founder at Quix.
And yes, we are here to perform the most dangerous demo ever. And we've gone a bit of a clickbait here with our title, but we are actually scared. You will see that this is quite a dangerous thing we are going to do as we write code, build, and deploy in real life with you, and asking for your participation. Then for your participation, we are going to need that you prepare your QR readers in your phones. So please have them ready. That's all you need to do to help us build this. Now, before we actually start with the demo, we want to introduce ourselves and also tell you a bit about streaming for those in the room that don't know about it. So, Tomas?
Thank you, Javi. So we have met in McLaren, 4 co-founders, and we are building a platform to get and process real-time telemetry from F1 cars. It's a quite demanding environment. We were getting around 50,000 parameters or channels from each car. Some of them were more than 1 kilohertz. That means basically 1,000 different numbers per second. And lots of models and simulation. And what we have found that it's actually quite difficult to build end-to-end platform that accommodate development, deploying into production, and is friendly for all participants like data scientists, engineers, etc. So that was where we kind of get the idea. Can we make it easier for others? Can we not make everybody go through this painful, long journey to get such a platform so they can build applications? So, Javi, can you talk a bit about streaming and streaming versus batch, please?
Yes, as Tomas is saying, streaming is at the core of Quix. We are nevertheless a streaming data platform, just as he was saying, that tries to make all the difficult bits easier and faster. So the traditional way to present streaming is as opposed to batch. Let's think of data flowing as that river that we see over there. Under the batch processing approach, a set of data is first collected over time and then fed into analytics systems. So in our metaphor, we have a bucket that is picking the water from the river, and periodically we throw that bucket into a lake. In other words, coming back to data, we collect a batch of information and then send it for processing. Now, with the streaming processing approach, data is fed into the analytics tools piece by piece. So in our river metaphor, we build a pipeline between the river and the lake. That is, the processing is done in real time. So you can use batch in situations where you don't need real-time analytics. However, when the value of your data is going to decrease over the time that it takes you to act on it, then streaming is going to be key. Let me tell you an example. I used to work at a telecom company, and the approach there was the traditional batch. So there will be different systems where the data will be collected over the day. So we will have a database for calls, another for the internet, and then at night, the data engineering team had created some jobs that will send that data to the data lake. Here, this data lake, composed by different layers, will first load the data, then do aggregations and different types of processing. And it is here in this final layer of processing where the machine learning models will live. So my machine learning is making predictions at night based on the data from that previous day to produce scores for the next day. And this is the issue with batch, the delay that we insert. Now, if my previous company was using streaming, there will be a topic for the calls, which is taking real-time data of customers' calls, another for internet data, SMS, and we could have another topic that is listening to those three to produce real-time predictions. I've been talking about topics So what are these? I'm going to introduce you to the basic concepts of a streaming system. First, we have topics, which in our previous metaphor will be the pipes that connect the river to the lake. We also have to have a producer. A producer publishes data into the topic, but as opposed to a database, you see that the data is not persisted in there. It's not necessarily persisted in the topic. It is available for some time, then it's not. At the other side of the topic, we will have consumers that are subscribed or listening to the data. And another big characteristic of streaming is that this system is asynchronous. It doesn't matter how many consumers we have on one side or how many writers we have on the other, it is going to work. It doesn't matter at which rate the producer is publishing the data or at which rate the consumer is reading it, is going to work. Now that you understand a bit about the basics of streaming, let's start the demo, Thomas.
Cool. Thank you, Javi. So now is the time to get your QR readers in your phone ready. I'm going to go to Quix, and here I have prepared a single front-end application, which is basically just a chat room discussion app. So you enter the room, and you can have a discussion. So I would create a demo A room. I will enter it as a Tomas. And now, if you can just scan this QR code and join me in discussion. So, hi all. Cool. Hopefully, we're not going to ruin the Wi-Fi here. So, nothing really special is about this. We're using Quix to redistribute the messages between you. And for that, we're using WebSocket Gateway that is provided by Quix. So I'm going to wait for your messages. Cool. So we have first one. First. Oh, Joe is joining us. Cool. So now, if I go back to our presentation, yeah, thank you very much. So the basic architecture is this. The WebSocket Gateway just is a middleware between your browsers and your phones and Kafka. But now is the core thing. How we can analyze your messages, how we can analyze a Discord in the room, if the sentiment is positive or negative, in a way that we're not introducing any delay, and it's scalable. Obviously, sentiment analysis is something where we need ML, and to do that, first we need to train the model. Now, that's actually still the same. So you process data over some time, then you label them, and you pull them to something like Jupyter Notebook where you train your model. Now, that would basically work like this. I will go to database, and here I have a stream called demo A, and here are the messages which you get before. Now, how we can, cool. So this will take some time, and we're going to skip that today. We don't have a time for that. So let's focus on how we can actually use that model that we train in that training real time. And this is where we're going to use streaming processing. This is where we're going to use something which is called pop and sub, and in-memory processing. So we're going to subscribe for a topic where your message is being streamed from your phones. And we're going to load the ML model into memory, get the sentiment, are you negative or positive about this? And then we would publish the score, the negativity or positivity, to the different topic, which then is sent to your phones. So let's do that. I will go back to Quix, and I'm going to use a library, which is just a project generator to get you going faster. I'm going to choose the template called model, which is exactly the pop and sub thing. I'm going to subscribe for messages from you, and I'm going to output it to sentiment. And I'm going to save it as a sentiment demo A project. I will get a Git project, which I can clone to my local environment and just use my PyCharm or anything. Or what you can also do is use our web-based IDE with Kubernetes-powered cloud-based development environment. I'm going to do that today. So first of all, we're going to use Hugging Face model, which is something that's already been done. I'm going to help myself a bit with the Quix docs here, because we have many code samples there, and I'm going to just use this one. And I will go to requirements and just add this pip package here and install it. So Javi, when it's installing, because it takes some time, can you talk a bit about this model, please?
Yes, some of you may know Transformer is a library, a Python library that Hugging Face has made available. And it is quite a useful one. It allows you to access NLP and other big deep learning models that we as little players wouldn't be able to train ourselves, right? So here in this instance, we are going to be using the Transformers pipeline object. This is a wrapper that makes much easier and actually really simple to perform any type of predictions on these deep learning models that have been trained by Google or other big players with lots of data. Today, we are going to be using the pipeline from Transformers to do sentiment analysis. We are not going to be changing anything of the standard configuration. That means we will be using a BERT model that is a bidirectional encoder representation from Transformers. It's just a state-of-the-art NLP model that Google AI developed like 3-4 years ago. It's already installed. The library is already installed. So Tomas?
Cool. So I'm going to borrow a couple of lines from our codes example in GitHub. So I just get going faster. So first of all, we need to import the library. That's easy. And then we need to load the models from the repository. That's going to be those 2 lines. And then I need to get how to use this, actually. How to, when I get the message, how to get the score. Are you talking negative or positive about this demo? So it's these 4 lines. And that's it. So here I would do some changes in our template. So first of all, I'm going to listen to events, that being your messages. You see that I'm getting some hints here. I would remove this template code. We're not going to need that. And there we are. I'm going to listen to each stream. So each stream is one chat room. So we kind of bundle this together. And I'm going to basically get the message from you into this classifier. I get the score. And to see something, I'm going to print it to console. And I'm going to print also score. So we get something now. Let's give it a try. So actually, you don't have to send new messages this time, because we're using Kafka under the hood. And it gives us quite a cool feature, which you're going to see just in a moment. So I'm going to run this code. You see it's being downloaded for first time. We get this. Because it's happening in the cloud on my laptop, it's actually quite fast. And now we're listening to stream. And you see we already get the messages from you guys and the Bitcoin that I did before. Why is that happening? Well, that's because Kafka has a temporary queue that persists the messages for a limited amount of time. So when you have a downtime, you basically don't lose the data. Or if you're upgrading your models, etc., you don't lose them. So that's fine. I will stop this for now. And go back to the project. Sorry. And now the question, how I can get this into your phones. So we're going to use Quix SDK, which is basically a Python library that helps you to read and write messages to Kafka and from Kafka so much easier. So you can basically write or read Panda data frame with one liner. That's just to help you going faster. And Cool. So we just process to the end of the queue now, and you can see weather is always amazing, positive. The weather today is pleasant, not positive. Then lol was done as negative, etc., etc. So Javi, can you send another message? This is bad, -1. There you are. So now let's get this sentiment into your phones and a bit more. So I'm going to stop this. This presentation is funny, cool, great demo, cool. I will stop this and let's continue. So first of all, I will here, when I get the score, go to stream writer, parameters. So I'm going to send tabular data. Each row in our platform has a timestamp. And it's actually nanosecond precision. That's just inheritance from our racing background. Most of the time you don't need it, but it's there if you need it. I'm going to just pass the tags. Nothing important there. Your name is there, etc. And now I'm going to add a column with sentiment. So that would be sentiment and the actual score. Then another column would be the message. I'm going to just copy the message to the output stream so I make my life a bit easier here. And then another column would be average sentiment. I want to measure every sentiment in each room separately. Now, Quix SDK is going to help you with that because it holds the scope of each stream in a callback. So for me, it's going to be just easy as basically going here. First of all, naming the output stream sentiment. So what the front end is expecting. And here I'm just going to have a sum equal to 0 and count equal to 0, 2 parameters. And quite soon you will see what I'm doing here. So I will, every time that I receive the message, and by the way, this is a big difference between batch and streaming. This piece of code would happen every time you send a message. There's no batching, and that's why there's no delay involved. If you're on a good internet, we are talking about 30, 40 milliseconds to basically send your message from your phone, get to cloud, get processed by ML model, and being streamed back to your phone. So quite fast. So what I wanted to do here is basically every time this happens, add it to the sum and count equal count plus 1. It's just a basic average. And I'm going to call this rolling sentiment. So sum divided by count. And that's it. If I haven't done something wrong, I'm going to save it. I'm going to run it. Now, if you can just refresh your page in your phones, and I'm going to say something like hi, and there we are. So the projector is really bad, but you see the red and green on the left. On the right, you see the rolling sentiment. So if it's red, it's negative. If it's green, it's positive. And on the right, now we're getting a bit negative. And if you guys get more negative, it will go down, etc. This is it. So now I can analyze if you like the demo or not. Dentures, demo, red, green. Yeah, so we are on a 0, so it's neutral. Cool. So this is working, but how we can get this? How we can test this a bit more? We need a bit more data. So I actually built a little Python code in Quix to subscribe for tweets and get the messages from Twitter into the chat rooms. So for example, if we go to a Bitcoin room, I'm using Bitcoin because, as you can imagine, lots of people talking about Bitcoin on Twitter. So if you use your QR code reader again, you can join me in this room. And I will go and start this bridge in a second. So there's a Bitcoin quit the Bitcoin. It's being deployed into Kubernetes, starting, running. Now, in a moment, it will subscribe and send, oh, there we are. And as you can see, lots of people talking about Bitcoin. So now what I'm doing is, in memory, getting those messages as they're being published to Twitter. And with no delay, I'm measuring their sentiment. And I can react in milliseconds to anything here. And you see lots of messages being processed. Now, this is powered by one cloud. And less than, I think it's 400 megs of RAM, which you need from the model. And it's scalable because there's no parsing. It's a basically a marriage of Kubernetes and Kafka. There's no engine like Spark or Flink under the hood. So that's why it's so efficient. Now, let's talk about how you can make this from a dev phase that you just saw in my IDE into production. So I will stop the Twitter one, because there's a limited thing you can get for free. And with the Bitcoin, you will run out of quota quite quickly. And here in this IDE, I will stop the code. And if I go to version control, I get a Git under the hood. And I will tag the latest Git, because latest commit, because it's working. I will tag it with the version 1. And then you are, from having this in Kubernetes, 2 clicks away. You press deploy. Let's call it sentiment demo. Yes, let's use the version 1 as a service. Let's give it 1 core, 1 gig of memory. Now, if we will get bonkers, obviously here we can replicate this processing to 8, 10, 20 instances. And Kafka and Kubernetes will work together to give you that. So we would use what is called Kafka partitions and Kubernetes replica. And basically, they would share the load. And it also would help each other if there are any downtimes between different instances. And when I press deploy, what's happened is that this Python code gets built into Docker image, and then, using a Helm chart, deployed to Kubernetes with just under the hood. You can download Docker image if you want. You can change Docker file. You can edit it, but you don't have to. It's there for you, and it's just working. You also get monitoring, logs, build logs, everything that you probably want to have in any sensible environment for development and production. Now, if I, for example, get this front-end app that you were using, and I check the logs, this is basically just getting the logs from Kubernetes from the pod. There's nothing special about that, but it's something you have to do in command line. It's not that cool. So yeah, that's the demo. It went well. Nothing broke, so I'm quite happy. So Javi, can you? Before I give the word to Javi, it was just last bit. You see, there's one really cool thing about this. This works without any database. Databases are quite often a hurdle for scaling. They are expensive. They're hard to scale. But this is what we did today, involved no database at all. You need a database for training, but you don't need it to run your processing. Javi? Yeah.
So I hope you've liked this demo and you've seen the performance of streaming and how simple it could be to build. We've done it in less than 20 minutes today. What I want to show you now is which industries are already using this. Some of the early adopters have been the gaming industry. They are using streaming to detect chatting, to monitor chat rooms, or increase playing time. Also thinking finance and fintech, especially with fraud applications. Real-time streaming is very important, both for the model predictions and also to do some sort of online learning, retrain those models to react to what it is a very changing environment. Streaming is used in e-commerce and retail for recommendations, or in mobility industry to track and optimize the fleet position. And it's been used in media and entertainment or telecommunications more and more. So why is the data industry going into streaming versus batch? This is a recent McKinsey report, and they give the 3 reasons that I hope you, by this time of the demo, already sort of agree. First thing is obvious, data is always up to date, so it is processed and executed when it has the most value. Very similarly, this low latency makes that the delay is minimal. But Tomas has just said this. It's also very cost efficient. Processing before storing means a lot of efficiencies. So we are not talking about big data dumps in here. So why it's not being used that often if it's good? We find that most people think they don't have streaming data, whilst if you think about it, every piece of data is created in real time at any company. There's also this misconception we have just discussed that streaming is expensive. And finally, streaming has traditionally been difficult, and that's because only big players like Uber, Booking, LinkedIn benefit from it. Netflix will have their own streaming system built, but little players wouldn't be able to do it. I hope we've shown you today that that's not the case anymore. There are ways to build streaming applications faster and simpler, and I hope you guys have this interest for streaming some way as much as we do. If you have any questions about the demo or streaming or Quix or what you have seen today, we are here to answer. Thank you.
So if you guys have any questions, just raise your hand, keep it concise, and I'll come and listen to your question and repeat it back, because we're not handing the microphone over.
Thanks for the presentation. So basically, I have a question about ML models. So let's say you have some streamline of data, right, and you have some trained model, but then maybe as time goes, like you want to train a new model, but you don't want to stop the stream, and you want to attach this new model in the future. Do you allow doing this in your
Yes. So first of all, when you saw the replica system there, it's one of the cool feature of it is rolling update. So as you updating, some instances get new versions, while the others are taking the load of those that being shut down. And also, you can basically load the new version of your model in memory. In the model. So you don't have to restart it. So there are multiple ways how you can do that. Usually, if you're going to train your own model, you're going to probably have some sort of catalog or S3 bucket where you store your artifacts, your pickle files, and you can just send the event to the model, say, load this new version, it will load it and continue processing. And the others will take.
In terms of how to use new data to retrain a new model, topics don't need to store the data. That's the point we wanted to make, but that doesn't mean you cannot store data. You actually can store data if that's what you want, and that will be an option. So you store this new incoming data that you want to use in the future to retrain your model. Simple.
Or you can use online training as well. There are multiple. Does it answer your question?
Yeah, you can just speak up.
Can you also do real-time topic modeling?
Topic
modeling. So you classify all your tweets or chats into a specific topic, whether it's about, I don't know, just new movie or new game or new events that's happening.
So are you asking if we can process multiple different sources?
Yeah, so you're doing like a tweet or a chat is positive or negative. Say, for example, I get like the recent COP26 event, and they do different things about, say, talk about the environment, food, agriculture, so we do real-time modeling, topic modeling, classify each tweet into a specific topic.
Understand. So one of the examples we have on our website is a city mobility example when Javier built project which predicting number of bikes available in New York and London, and it's using API of the service, but also is using weather, and it's combining them together to predict if there will be lots of bikes available or not. So that's an example where you have two different data sources being combined to one output. You can subscribe for multiple topics in our processing service. It's just a Python. So you can do whatever you want. You can mine a Bitcoin. It's just a Python service. And if you are interested more, you can check the mobility example, and there's everything, Python code, architecture diagrams, how to combine it.
Yes, but basically, yes, you can build anything you want. We wanted to show you here more the MLOps environment that enable these streaming applications. But in terms of the use case, the type of machine learning model, you can basically do whatever you think of.
Yes?
Yeah, sorry. When you were scrolling in the GitHub, I saw that you had a dictionary with words like love, and you have elk, not me. How do you come up with this dictionary?
Yeah, so this, I haven't used it in this demo. It is an example. So there are certain emojis that, if you want to do it properly, which in a sample code it's done properly, you have to first do some replacement. So for example, the laughing emoji is translated in some text that is being properly measured by the ML model. So that was just that. I think we have downloaded it somewhere from the internet. It's not that important. You need to come up with a certain replacement for things that would make the model go haywire.
Yeah, and one second question. So how do you handle for example, in real time, you're in a stadium and there are streaming messages. How will you handle like people who are not speaking English, the different language, or mix, like Spanglish or different language? How will you handle your model that?
So in this particular case, I would probably have probably a model that would probably detect the language first, and then stream different these discussions in the different streams, and then I would have on different streams different version of this model. So you can see in the first two lines I used there, you set the language there. So, and you also set the optimization. So this one optimized for Twitter. So you will deploy a different version of the model. We support environment variables. So what you can do is just deploy this sentiment analysis with 5 different settings, and for English, Spanish, French, and it would take its own data. And also, there was a line when I said add tags, if you remember. You can tag your data accordingly as well. So another way how you can do this would be just read the tag from previous processing, what type of language it is, and then use the right model from your collection.
The library you talked about, does it also consider the typos that we have, like the small typos?
Yes. It considers the context of the textual information, so it doesn't just take word by word. It is the whole sentence. It takes into account potential typos. It's quite an advanced one. We didn't develop it. It's developed by Google with all its textual information. So yeah, it takes many little things into context.
Well, there's obviously Docker as a technology. Then when I showed you the database, when I showed you the database, we use Influx, Mongo, blob storage as well. But for the crucial part, where you process the data, it's really just a Kafka and Kubernetes, and Docker for building that image so you can run it in Kubernetes. But it's a marriage of Kubernetes and Kafka.
Yeah, there is one more there.
Right, so in this system, you're scoring things in real time. So can you talk a bit about model monitoring and how to prevent certain nasty things from happening? So in this sentiment, so maybe in a different example, you might be classifying content as being racist or not. Can you talk about model monitoring and how you stop that from happening in a real-time environment?
Yeah.
Yes.
So basically, you can apply different models in a pipeline. So it could be multiple stage. And one of the examples could be that you train a model to detect bad words and bad matters in a discussion, and you can replace them with a start and then continue in your pipeline. So that could be one example. So basically, you write in the chat, and in 40 milliseconds, it will be marked as abusive and sent back to the chat room. Javier, do you want to say more about the?
No, yes, basically that. We focus today about the MLOps, the infrastructure that you need to have a system like this, machine learning model as big as this, predicting in real time. How you combine different models or how you build a more advanced infrastructure is up to your use case. And as Tomas said, in this case, you could do perfectly that. You could have different models in series at different stages, each of them performing a task. One of them could be detecting abusive language to then tag those messages or ban those users.
Any more questions?
I would like to ask about like the queue system that you mentioned earlier.
Yes.
So how are you going to store the queue? Is it like going to be in database or?
No. So Kafka provide this queuing system. The way how it works is that per topic, you say, I want to keep these messages in this queue for either certain amount of time, default is 1 day in Quix, but you can configure it, or amount of data. And the way how it's done is that the leading edge is usually in memory, done by Kafka, and then if it takes longer, it's offloaded to disk. And there's a system of consumer groups. I haven't shown this today, but it's in the code. You can basically identify self as I'm consumer number 1, and Kafka keep what you have already processed. So when I shut down the service and connect again, as long as I'm consumer A, Kafka would subscribe me to the same offset of messages where I left. But if somebody else joined it as a different consumer, he will start from the start. And this kind of is very helpful for things like downtime, upgrading stuff, and sometimes for development. You don't want to stream it every time you did one line of code. You just change the consumer group and you do it again and again. So it's quite practical.
How do you handle outages of data sources? For example, Twitter crashes. Do you continue trying to fetch data, or and the system crashes, or yeah?
So this is really up to the use case. I don't remember how exactly the streaming API of Twitter is done, but what we help with, and we cannot do much here, but what we do is that if your bridge, if your code that getting the data, whether it's pull or push, into Quix, crash because of data source being crazy, your service just gets restarted and tried again. But that's what we can do. I mean, if Twitter gets crazy, then we would just try. Your code would try either by you, that you do some loop in it, or if you don't do it, we will restart your service regularly to try to get working. But that's what we can do.
Just going back to the first question around storing data. I know you mentioned you don't need to store it because it's done. So in terms of data lineage and also be able to go back and see, interpret what your model's done, where would that sit in the MLOps process if someone wants to say that, and would that slow the current process down in terms of the real-time stuff?
So although we are not really a database platform, we have the database exactly for this. And so what we recommend do with Quix is that you attach a metadata to streams and you persist them. So we bundle data with the streams into stream database, and then we attach certain metadata. So you can, for example, attach the version of your model, and then in our data catalog that I showed you when I was showing you the messages that you already stream in database, you will see the version that has been behind this processing data. So that's how you would be able to track. We also keep the data lineage of different topics. So imagine you have data coming to topic A, then you process it to topic B, and then maybe you have abusive model, so that's topic C, and you go in jumps like that. We take care of that lineage, and in our platform you can have a tree view where you see different streams of different models being responsible for that pipeline, and also which version of each step used.
Also, because this type of data tends to be time series, we are talking about streaming, so you have a timestamp and some values. We have certain specific database in place, like InfluxDB, I don't know if you know it, which is specific for this type of data. So although, as Tomas said, we are not a database-centric platform, the type of data that we store, we do it very efficiently in terms of being very specific about its format, which is going to be time series.
So it's Mongo database for metadata, Influx for time series data, blob storage for binary data. We just use different database for each data type because there is not an amazing database that solves everything. So that's why we do use different tech for each.
Thanks for the talk. And how do you go about choosing like Kafka versus some other queue system like NSQ?
First of all, this comes back to McLaren times. We were presented with a problem that was already big. So it was an enormous amount of data. And therefore, we had to choose a technology that's going to be very performant. And we kind of had to go through testing different. And Kafka turns out to be most powerful. It is a difficult technology to manage. That's why we got the idea about Quix. It's the configuration and everything is just a nightmare. But the raw performance, I believe, is one of the best. And if you compare it, for example, to things like MQTT or other systems that were before, it's much, much better.
Thank you so much for your questions, guys. Unfortunately, that's all the time we have for this session.
So thank you, everyone, for participation and helping us to get it going.
Thank you.